Hey guys, so I'm here to do local resting and action potential. Sorry, there's a cat in the way. So here is a neuron. So this is at its resting state. It's just sitting here, not doing anything. I have some key points about it too. Sorry, that was kind of vague. A resting non-signaling neuron has a voltage across its membrane called the resting membrane potential, or simply the resting potential. The resting potential is determined by concentration gradients of ions across the membrane and by membrane permeability to each type of ion. So I actually have another graph to show you like the internal of the neuron, like what happens inside. So starting state, there are potassium ions and other ions, including anions inside and outside the cell, so like the proteins. Potassium is more concentrated on the inside and less concentrated on the outside of the cell. So it's just kind of showing you where the starting state of a neuron is. The resting state, we'll take that away, and then we'll just keep looking at this because I'll explain a little more. And then I'm going to explain local potentials. Incoming sodium ions produce a current that travels from the point of stimulation through the trigger zone, which is the axon hillock right here. So that's going to send down that action potential and go all the way out right here, and then it's going to go to another muscle or another cell at the end. An action potential nerve impulse travels down the axon. There's a change in polarity across the membrane of the axon in response to a signal from another neuron. Sodium and potassium gated ion channels open and close as the membrane reaches its threshold potential. So the local potential. There's another thing I kind of wanted to point out as well. If potassium channels in the membrane open, potassium will begin to move down its concentration gradient and out of the cell. Every time potassium ion leaves the cell's interior loses a positive charge. Because of this, a slight excess of positive charge builds up on the outside of the cell membrane, and slight excess of negative charge builds up on the inside. That is, the inside of the cell becomes negative relative to the outside, setting up a difference in electrical potential across the membrane. So again, I wanted to show you guys just like the internal, like what it does on the inside. So as you can see, if potassium can cross via channels, it will begin to move down its concentration gradient and out of the cell. The movement of potassium ions down their concentration gradient creates a charge imbalance across the membrane. The charge imbalance opposes the flow of potassium down the concentration gradient. I hope this explains local resting and action potential for you guys. Thank you.